design patterns for enterprise development. Really, what this comes down to is learning from others what works and what doesn't, right? It's not a question of if you build it and they will come. It's how you build it, right? That's what we're going to be focusing on now. So, it really comes down to common sense. Right from when we were very young, you would often learn through trial and error. You try something out, see what worked, and if you made a boo-boo, if something went wrong, well, then you try a different way, right? And hopefully over time you learn what works well and what doesn't. Well, that's good as far as it goes, right? But at some point, hopefully we learn from others and their experience as well. So we're very fortunate in this industry that software developers have shared what they've learned through their experience, and we can benefit from that, right? And through many years of testing and verification, there's a lot of confidence that certain principles and certain patterns really do make a difference, that they improve our ability to reuse our code. And that obviously increases our efficiency as a developer. Other big aspects of this is testability, right? That's one of them. I can guarantee you right now, when you graduate as a graduate of our program and you're out there working in industry, you're going to be doing a lot or focusing a lot of your time on testing, unit testing and testability of the software that you're developing. It's the only way to be confident that you can actually continue to build and maintain reliable code, right? Is to actually start off and build it on good a foundation of design patterns and principles. And this is nothing new, right? Right back in ancient times, any kind of builders have done the same sort of thing. They've learned, right? So even boat builders, they learned probably from a parent being passed down the techniques to a child or whatever, right? And this has been true in everything. Engine designers, talk to any tradesperson, right? And as an apprentice, they were taught, this is the right way to do things, right? As they were learning the skills and their trades that they've learned themselves, right? So it's nothing new. Now, the first published catalogs of standardized design patterns were probably those put out by architects, right? But it only makes sense then that software engineers would follow this and do the same thing. And we're fortunate that they have. So there's, if you go to university and you take a course on modern design patterns and so on, there are certain books, certain references that stand out in the history of developing this in software engineering. One of the most important, right, is this book here, the actual title, Design Patterns, Elements of Reusable Object-Oriented Software, published in 1994. These links, you'll have a copy of this PowerPoint. These links actually work. And you can go to some references about these different books and so on. But this is often kind of referred to as the Bible of object-oriented programming software design, right? There are 4 key authors in this book, and if you follow the link, you can get their names. I'm not going to go into that much detail here in our discussion, but they're often referred to as the Gang of Four. So the book itself often was referred to as the GOF book. And the first few chapters talk about general principles and things of object-oriented design, and then they get into specific patterns, and they even number them, right? So after a while, people would often refer to, GOF pattern number X, right? And refer to a specific pattern out of this book. So it became one of the most famous and initial books of its type, cataloging modern design patterns. But to be honest, though, look at that date, 1994, right? Now, much of their work focused on C++, and everything in this book is still 100% valid, right? And sound. So, it's certainly still used quite often as a reference, but the languages we're using have developed since 1994. And as a result, some of the patterns are basically less important than they used to be because they're automatically implemented into the newer design tools that we have to work with in our more modern languages, right? Now, a more recent book, early 2000s, was this one here by Martin Fowler, okay? Catalog of Patterns of Enterprise Application Architecture. So, this is a quote directly from one of the reviews of the book. They say that Martin Fowler took design patterns to the next level, right? And one way he did that is he also covers scenarios that didn't exist even, in the decade earlier, right? Distributed systems and so on. So the only kind of complaint about this book is it's extremely technical. And, some people find it a little hard to follow from that point of view, but it is also regularly and routinely pointed to as one of the main resources to discuss modern design patterns, right? Now, just to mention, I believe it's O'Reilly Press have put out a number of books in their Head First series, and they've got two out that I know of on Head First design patterns, a bit older one and one more recently published. And I highly recommend them if you're looking to go out and just get a book that you want to have a reference for design patterns. They're very easy to read. They use a lot of fun anecdotes as they describe and detail the different patterns. So, I wouldn't quite call them design patterns for dummies, but it's written in a much more easily digestible language to some degree. So, as I said earlier, if you were in a university course on software engineering, you would probably have copies of most of these books in your library already, right? And by all means, refer to each and every one of them to your heart's content. But if you're just starting out and you want to get a book, I would maybe go for one of the head first ones. That's for sure. Okay. All right. But just want to mention that's if you were at university and studying nothing but software engineering, then that would be, your goal. Our goal in this course, I just want to point out, is slightly different, right? We're a college, right? We focus on not so much all the theory, but on actually doing something, building something, right? And that's what we're going to be doing. So we're going to be building a fully functional, you might even call it a full stack type application because we're going right from the, fine tuning the user experience right back through the whole system to the very back end and the data persistence mechanisms and so on, right? A number of years back, in consultation with our advisory council, um, the faculty got together and discussed the idea that really what people are asking for is it's great to cover a little bit of that and this and the other thing and so on, but we need to be able to give our students experience of actually building a full scale sort of application, a full stack type of an application. And this course was highlighted, or in our discussions, as one that was probably a really very good opportunity to try and provide that experience as part of our program of instruction, right? So as we go through this course, yes, we're going to be discussing and implementing a number of these design patterns, okay, the ones that are particularly relevant to the success of the application that we're going to build. But our goal, our focus is on actually building an application. So we aren't going into all the details of all the different design patterns. That's not what we are about, right? We're going to be focusing mostly on one particular pattern, Model View Controller, right? MVC design pattern. And we'll be using that throughout the course. There are other design patterns that are important to know, and there are many others that we're going to be covering. And as we go through and we start utilizing different ones, we'll point them out and we'll show you how they fit into the application that we're building and the approach that we're taking, right? But this is not about everything in terms of the theory. It's about actually building something that you can then have as part of your portfolio, uh, highlight as something that you've achieved, both to friends and family and to potential employers down the road, right? Okay, so let's talk a bit more about MVC and what is the definition of this particular pattern. Model View Controller, that's what MVC stands for. Now, just remember, it's not a language or anything like that. It's a framework for building something with, right? It's a programming design pattern. And, it goes right back to the late 1980s. Smalltalk was the first programming language where MVC was formalized as a design pattern. But it's used all over the place, all over everywhere in industry. If you can do it with PHP, you can do it with any language that you want. But many languages depend on it, right? Ruby on Rails. You've probably heard of that. If you do any work with Ruby on Rails, you are using the MVC design pattern. Java, right? The Java language itself, if you just start a new Java project, the template that is used to as a starter is based on the MVC design pattern, right? So not only is it just about everywhere utilized in industry, it's also something that our graduates tell us, many of the jobs that our graduates are getting relate to or directly use the MVC design pattern. And there are many variations, model view update, model view view, and so on, MVVM, model view view model, they all kind of relate back to some degree. So learning this pattern is very important for your future career. We'll be implementing it, okay, using ASP.NET Core and C Sharp, right? We'll talk a bit more about ASP.NET Core in a few minutes. But as I say here in plain speak, it's really just a way of organizing the code inside your project, okay, and the flow of control as well. And that's all intended to make our project work easier to develop and maintain. It can be the best choice in many situations for something that's going to scale up to a very large enterprise level application, but you can even follow this pattern even for a very small and simple application as well. Okay, so just to talk a bit about some of the other select patterns that we're going to be learning about and using and implementing as we do our work. One of them is the unit of work pattern. Now I'll go into more detail about many of these in our slides coming up, but just to mention some quickly. Dependency injection, right? Very important in modern software design. It's a pattern that helps us implement the principle of inversion of control. And I have a story to kind of relate that to you coming up in a minute or two, right? The repository design pattern, okay? Very important, used tremendously, very commonly, sometimes referred to as a service pattern, but I think it's more accurate in our situation to refer to the repository design pattern. Separation of concerns, very important. I know you've talked about that before in your work with learning classes in C# and so on. There's client and server-side session state is touched on as a design pattern in the work we're going to do. And there are many other ones that I know you're already familiar with, right? From your earlier work with database design, right? Things like the concept of every table having an identity or unique identifier, foreign key mapping, association tables, and so on. Or sometimes we call them intersection tables between two entities so that there's a many-to-many relationship supported and so on, right? Concurrency and so on and so forth. So many of these you've touched on before, but we'll be utilizing them again in the style of software development that we're going to learn in this course. Okay. And the other thing I'm going to mention, though, before we get into details on any of these, is that what you're going to discover is that ASP.NET Core MVC, especially using it with Entity Framework, makes implementing many of these patterns almost automatic. So it's just part of how we do it, right? So we don't hardly even have to think about it. So I'll always try and point out and say, oh, here's where you can see we're using dependency injection or the repository pattern and things like that. Okay. So just to talk a bit more about some of these, because they're very important in what we're going to do, the unit of work pattern, formal definition given here, right, maintains awareness of objects affected by a business transaction and coordinates the writing out of changes and the resolution of concurrency problems, right? In other words, if we get data from the database and we make any changes, well, we need to keep track, right? What's been changed, what hasn't, okay? Sometimes we'll use observable collections in some situations, things like that, but we have a certain way of doing this in MVC, right? And then we want to make sure that all the information is properly written back to the persistence layer, whether it be a database or some other layer, right? And new objects have to be inserted. We have to remove ones that are deleted and so on. So we keep the data storage in sync with all the activity and transactions happening in the business end of the system itself, right? Well, guess what? The unit of work pattern is fully implemented for us by Entity Framework. So it's something that is just by using Entity Framework and following the approach that we're going to be learning just happens. It's almost automatic, you might say. And we'll see that with many of the others as well. The repository pattern, right? Here is where you have on the one side your data domain, right? Your persistence layer. And of course, as we often do with object-oriented programming, we work with collections of objects, right? So how do these relate to each other? Well, often through a repository. The whole idea is that we don't want to have to worry about all the details of how the persistence layer saves the data, right? Is it going into a Oracle database, or is it SQL Server, or is it a non-relational database, or is it just passing the data off to some web service of some sort, right? We don't have to care what's happening as long as it's doing its job. And we accomplish this in many cases, this repository pattern. What it does is it hides all that complexity behind a simple interface. An interface to deal with a collection of objects where we have simple methods to create, edit, delete, and maybe select in a number of different ways with filters or so on, or just select all and things like that. So those simple methods are presented in this interface. Now, how that interface is implemented in the background, why should we care? Well, of course, because we're going to have to develop it, we're going to care. But the point is, the front part of the application, everything in front of the repository, really doesn't have to care. It just knows that if I add a new or create a new object, that it gets saved, right? And the real beauty of this is it allows us to swap out the data persistence. Maybe we're going to change what database we're using, what database engine. Or maybe it won't even be a database anymore. It'll be some other persistence mechanism, right? And we can change all that behind the repository, but none of the code in front of it gets modified at all, right? So really effective for maintaining your system as changes are required down the road, okay? And also really simplifies the kind of code that you write because you just have this simple interface that you have to deal with. Well, guess what? This is also implemented for us by Entity Framework using our DB context object. It essentially is a repository itself, right? And has these different built-in methods to it with our different, we call them DB sets, our special collections. Now you can add your own separate repositories to this as well, but for the most part, we're going to follow the approach seen in the initial tutorials that we're going to have access to, and we'll just be relying on the DB context to do its work as a repository. Okay, dependency injection. This is really worth talking about because it is one of the most important patterns to implement a central principle that makes our code testable, right? We've talked about this earlier, the inversion of control, right? That is a design principle, right? As it says here, it says that the objects do not create other objects on which they rely to do their work, right? In order to have separation of concerns, they will get the objects passed to them from outside. And they're only concerned that the object that they're given implements the correct interface, right? And so dependency injection gives us a container that will build the objects that are required and pass them into all of our objects. This gives us loosely coupled code. And that is the key to having it easy to test and maintain all of our classes, right? I have a story I'm going to share in just a moment, but let me just iterate this first again. The purpose of dependency injection is to make our code maintainable and easy to update. If our objects don't directly depend on each other, then we can isolate them and test them and make sure that they're doing what they need to do. Okay? So maybe what I'll do is I'll read you the story of Sam and Hammer. That might help make this clear to you. All right. Once upon a time, there was Sam and Hammer. And there was also Bob, but we'll get back to Bob later. Sam and Hammer are classes in your application. Sam has a very important job to do, but is dependent on Hammer to get it done. Okay? Now, one way to make sure that everything works is to set it up so when Sam is asked to do work, Sam can go out and make a hammer, right? He can instantiate a hammer, or at least an object that fully implements the I-hammer interface, and carry on. Do the hammering he has to do and finish the job. Bob? Who is Bob? Well, Bob's your uncle. Success. Your app is working. Problem is, if Sam makes his own hammer, right, then you violated the inversion of control principle. Sam creates an object here that he's dependent on, right? He needs that hammer, he makes it himself. That tight coupling between those objects is a real problem for maintenance and unit testing. Make any changes to either of the classes, And there's a real chance of introducing bugs, especially because it's impossible to isolate both classes and test them on their own. Now, to make that clear, right, we'll talk about it a bit further. On the other hand, if we use a DI container, dependency injection container, to create the hammer, or again, at least an object that fully implements the iHammer interface, and pass it to Sam, Sam can get his work done, the application succeeds, and inversion of control is satisfied. And that allows us then to easily create unit tests that allow us to test each class separately, right? To illustrate it, imagine that hammer, the class hammer, involves a complex operation, okay? Perhaps using web services, database operations, whatever, right? Well, if we left the classes tightly coupled, we couldn't test the SAM class without spinning up the database server or whatever resource hammer required, right? Which would likely be a very resource intensive operation, making our unit test very slow and expensive to complete. Not only that, but we really aren't just testing SAM, because what if the test failed because there was a database connection error or something else that was an issue strictly happening inside of Hammer? Well, on the other hand, then with dependency injection, we can pass SAM something that looks like a hammer, implements the iHammer interface, but it might be a fake or a mock hammer, satisfies the requirements of the interface, but it just gives predefined responses, right? This mock object uses a minimum of resources because it doesn't actually do anything, right? But it allows us to do whatever testing we need to do on SAM. So by using dependency injection, they can all live happily ever after. Isn't that a nice story? All right, let's get back to it then. Okay, so fortunately, ASP.NET Core, MVC, has a built-in services, right? Services container, which is a dependency injection container, and it supports both the main common constructor injection and action injection, right, from services. So any of our classes, we can inject any of the services that they need, right? But they're still loosely coupled, allowing us to easily implement unit testing later on, right? There we go. Okay, so let's get back to MVC itself, right? Model View Controller, one of its great strengths is this separation of concerns is built into the design of the pattern itself, and it's enhanced with our dependency injection. But let's talk about what these three separate entities here really are doing, model, view, and controller. Well, the model is really sometimes referred to as the data domain, right? It's all the logic and the persistence mechanism for the data itself. If we need to work with data, we use the model, right? The view is really just a presentation. Okay, think of it as the web pages that we're actually going to see in a web-based application, right? That's the view. The controller handles all the flow of information within the app itself, right? It gets all the input, comes to the controller. It deals with the model, right, to get any data that's required, puts it into the view, and away we go. Okay. Just remember, of course, there's an arrow between view and model because the view is a representation of the model itself. Maybe another way to understand the flow of this whole system is better represented in my next slide, right? So how does MVC work? Remember for a moment that we are talking about a web application. And right from your very first course in web, you probably learned that the web is really just a request response cycle, right? You click on a link, it sends a request, you get back a web page, and that's the response. Of course, actually, it's a little more complicated than that. There might be, that request might have numerous responses because each and every graphic and so on that might show up on the page might require its own request response cycle and so on and so forth, right? But the general idea is request and response. So how does this work in MVC? Well, all requests are routed to a controller. The controller handles all the input, all the requests that come in. Now, reads the request, sees, oh, well, I'm going to need some data from the model. So it handles that kind of in the background for us. It goes and gets any data that's required, right? Puts it in the briefcase here, okay? And then it goes and gets the view ready. Now, what is a view? Well, view visually represents the model. Yes, so if you've ever done work, for example, with something like a mail merge in a tool like Microsoft Word, you know, you write this letter, it's a boilerplate template, right? Dear and then there's a spot there, a blank for the customer name. Thank you for being a customer since, right? And there's a blank there, a spot for the date that they first became a customer to be inserted in. Well, a view is a little bit like that, except it's written in HTML, right? And it's got spots where the data would be inserted to make it a customized response based on the request that came in. So that's exactly what the controller does. It hands this data off, gets it inserted into the view where necessary, and that forms the response back, right? And that's the whole flow. So, the controller really is like a conductor, I sometimes refer to it, right? It's the intermediary between the model and the view. It's kind of like the brain of the application, handles the requests, binds the data, returns the views, right? The view itself is the user interface, represents the model, and the model is our business logic as well as all the persistent mechanisms and so on, okay? So, if it seems a little odd at first, it'll make more and more sense as we use it. Now, bucket list of learning items. So coming into this course, thankfully, you're familiar with a number of the tools we're going to use already. You already know C#. You've done several courses using C#, and I know you've done work with HTML and CSS as well. SQL Server, SQL, right? I shouldn't say SQL Server, but SQL language you've worked with extensively in addition, right? So we'll be using all of those, and thank goodness we're familiar with them. jQuery is one that you might not have worked with directly very much, but don't worry too much. It's not a major part of this course. We'll be using little snippets of jQuery here and there, mainly just to add more interactivity to the user interface and give a little bit better user experience. It's not life and death, and they're usually just small little snippets that I'll give to you more or less. Okay, so some of the new items then we're going to be learning about is Razor, right? Now Razor is essentially a way to use C# language embedded right in HTML, okay? Entity framework, we'll be using the code first approach for that. And we'll be using LINQ, language integrated query, right? So we'll get away from having to write all of our SQL ourselves. In fact, with code first, even all of our create tables statements and so on are written for us by entity framework. So you're going to love LINQ, believe me. Okay, and then finally, all of the templates we're going to use come out of the box with Bootstrap, right? If you haven't used Bootstrap before, you're going to love it too, I can guarantee you. Just a quick mention, Bootstrap is essentially an open source framework for CSS and JavaScript that is used to make very responsive websites. It was developed first at Twitter, but is open source and now has a very active open source community, always updating it. We're up to version 5 right now. Okay, class resources. I used to have a number of PDF files, some free textbooks that I could distribute, but I've gotten away from doing that because, as you've seen, how quickly things are changing. Most of those free PDF books that I had are so out of date, they'll probably just confuse you more than help you, right? So I'm not going to really hand them out anymore. Videos, okay, made by Prof in class. I say in class, but as you know, we're running the course completely online this term again, right? But to be fair, like in 23 years now, I've been at the college. More than a dozen of those years, the last 12 years, I've been doing my delivery pretty much in a similar way. In the classroom, I sit at the front there at my instructor station, and you see everything on my screen on big projectors behind me. What I've done, as I said, for just about 12 years now, is everything you see and my voice, I record during the lecture itself. And at the end of class, I would post it in one of a couple different places, but usually on YouTube. And the feedback from students has always been very positive. They really appreciated being able to go back to all the lectures and demonstrations in class, watch them again because things go by pretty quickly sometimes. They can back it up, review certain parts of it, more than once if needed, slow it down or speed it up because sometimes I talk more than I need to and I can be a little boring, right? So you can have that flexibility to review the material to your heart's content, right? And feedback has always been good. So when COVID came along and everything was pushed online, to a great degree, the only thing that really changed in how I run my classes is instead of being at the front of the room with you sitting in front of me, is I have to record them in my home office instead, right? And then I post them, right? So it misses some of the interaction where you could ask questions and you'd hear your own voice in my recordings. So I'm sorry for that, but for the most part, it's the same style of delivery, and usually I get pretty good feedback on how helpful it is, right? There'll also be a number of online tutorials that are free that we'll be referencing and using throughout the course itself. And I have a lot of resources posted up in Blackboard for you to look at, and I'll be going over a lot of those in your first class with you. Tone of the course, right? You're not in first year anymore, right? This is adult education, and this will be run more as an adult education style course, right? I'm not here to spoon feed you. I'm here to guide and mentor you, right? So you're going to be learning by my demos, but also by playing and discovering on your own, right? Throughout the course, you're going to be doing two key projects in parallel. My classroom example, I'll once again be using my medical office example, doctors and patients and so on. Not because everyone likes playing doctor, but because it's a familiar scenario. The model itself doesn't get in the way because it's easy to understand, and so it makes a good teaching example. You're going to be doing a homework project in parallel. So I'll show you how to add a certain type of functionality in the classroom example in the medical office, and then you'll be assigned, to do some project work on the other homework project to add similar functionality. And it'll work in parallel throughout the whole course. You'll be handing in your homework project at various stages for evaluation and marking, right? And we'll talk about the specific way marks are broken down as we have our first class. But that's generally how the course is going to run. Okay, so in terms of initial homework, right, up in Blackboard, there's the link there for this Get Started with ASP.NET Core MVC. So start working on that tutorial. There's 10 parts to it. If you can get through it all in the first week, great. I don't expect you necessarily will, right? I also encourage you, I put a link up in the week 1 folder on this background on MVC Core overview, right? By all means, read through that. It's a nice reference that you can take your time, read, and it explains the whole MVC approach very, very nicely. And I also suggest I put up a link there on Razor syntax because it's new to us, right? At least, glance through and become familiar with what's there, because later on, sometimes getting your code to work inside the view can be a little tricky at times, and it's good to remember, oh yeah, there was that reference that I skimmed through before. That's where it showed me how to, end one line in script and then jump to the next line in HTML and things like that. So that's enough to keep you busy for the first week. Next week, we'll start on some specific material. We'll get started on our medical office example, and I'll be showing you specifically some tips and tricks on how to get started building your actual application. But in the meantime, that MVC tutorial is a great, great place to start. All right, so that's basically it. So off you go, and I hope you really enjoyed the term. I think you will, and I know I will. Bye-bye for now.